Hey guys, Robo Theory back with my next video after end effectors, and today we're going to be talking about the microcontroller, and so let's get right into it. So in this video we'll be talking about the brain of the robot, which is the microcontroller, of course. And before I continue on, remember to subscribe and like, and let's get on. So what is a microcontroller? Just review that. So the microcontroller is used to control the sensors, actuators, and end effectors. So it's basically almost like the standard thing that controls everything. So it's basically the brain of the robot. And it is typically a small single chip, but can be as big as the one on the right over here, based off this main purpose. So you can have a small microcontroller used for like maybe a small robot, or you can have a big microcontroller like this one, XIQ. It's about this size, and basically these are used over here. They're used for output ports for the sensors, and then no, for the actuators, and then input ports for the sensors, and then over here we have the scrolling menu, the checkbox, and removing, and then of course we have a card over here, and then of course we have the battery which gets attached. So based off how big you want the robot to be and how like capable you want your robot to be, you can make your microcontroller however big it needs to be. So let's talk about why we need microcontrollers. Microcontrollers are the whole software structure. So remember, they are the whole software structure of the robot and command the actuators to move based off the given input from sensors and pre-instructed code. So that might sound like a whole lot of stuff that you might not understand. So let me show you a better view of how it looks. So here it is, and basically this is the microcontroller. I'll be highlighting which parts it actually shows. So the microcontroller almost just basically owns all of this. This is the whole microcontroller. So here we have stored data and stored instructions, and basically they're like step-by-step instructions of code that are used to run the whole robot in operation. So this is like the code for Java, maybe C, whatever code language used for the robot is the stored instructions. Then we have the stored data, such as sensor readings and variables are sent here, and I'll show you how that goes. Then we have the so now we have our sensor outputs to gather information about the surroundings. So such as input ports, such as sensors, gyroscope, distance sensor, touch sensor, all that input actually comes back to the processor. And this is the main thing we probably need to talk about, is the processor. And it's really important because it translates out the instructions from the input code. The microcontroller has to read two types of instructions. One of them is binary code, which only the microcontroller can read, and the other one is like the store data and store instructions. So it converts this code, like Java, C++, over to binary code using the processor. So all this input from the input ports and the sensors go through the processor, and then it goes back to the data. The data puts it through to the microcontroller, and the microcontroller puts it back through the stored instructions, and then the stored instructions gives it all to the output ports, the actuators. So here's how it goes. Input ports, processor, stored data, stored instructions, output ports. And so if you aren't using sensors, then of course it'll just be stored instructions, processor, output ports. So it really depends on either one you want to use. So this kind of affects the whole microcontroller field. I haven't done this with the other parts of the robot I've talked about, but of course microcontroller is really important. It's almost like the whole brain behind the robot, just like us humans. We always use our brains to think. Even when we're sleeping, we have dreams, whatever it is. Just like that, robots have microcontrollers, which has data, and we use input ports like senses, and the processor, which is almost like how our brain just takes one thing and processes it through how we take it, and then output ports, like our movement. So that's just another way to think about it. So how does a microcontroller work inside? So the microcontroller really starts out using code derived from the user. So the user writes code like a pseudocode on the right. So all this, this is all pseudocode, but there are also two steps of pseudocode, I would say. The first one is just writing basic instructions. If you want to pick up a block, then you can simply just say open claw, move forward, close claw, lift arm, go back, just like that. The second one is more of as specific to what the robot can actually do and what the robot can understand, such as initialization, take in the code, use sensor output to see where the block is, color code maybe to check if that's the right block, all that type of stuff. So that's the second. Typically it's used in like the comment feature of coding. So of course this is important to use. That's why so many people use comment feature, because they want to maximize their understanding of the code, maybe to a client or someone. And then of course the microcontroller takes the code, which is the processor basically, and translates it into binary code that the computer can read. So almost like 0, 1, 0, 0, blah blah blah. So binary code is a lot of letters, numbers, 0 and 1, that's it. So it translates it into zeros and ones, and basically these numbers, they translate into words for the computer. It's the only thing that they can understand. For example, if you only talk one language, you might not be able to, if you only talk English, you might not be able to talk Mandarin or any other language. So same thing here, the computer can only read binary code. So then the microcontroller takes it and translates into binary code, this, and then the binary code reads it through and then executes it by the microcontroller, which performs the command in the control code. Basically, this binary code, because we can't program in binary code, it'll take too much time. The processor translates the binary to binary code, and then the binary code is read through, which is executed by the microcontroller, which performs a command in the code, so the actuators and effectors. Now let's talk about robot effectiveness. Of course, this is just like sum up, and basically the robot's effectiveness is whether the robot is successful or not, and effectors, actuators, and sensors and microcontrollers all contribute to this statistic, data, analysis, and basically we use this to measure how effective a robot will be. If your robot does not have one of these, then of course the robot might not be as efficient, of course, but it depends on the robot's needs. For example, you might not need sensors, which I see a lot. A lot of people don't use sensors in like school programs and competitions, but that's still fine, because even if you do remove the sensors, the robot will be efficient, but not as efficient. And effectors, actuators, and microcontrollers are still important, especially actuators and microcontrollers. And yeah, so thank you for watching. Follow me on Instagram, and remember to subscribe and like. Thank you all.